Okay, in this video, I'm going to highlight a couple of the problems from the applications of quadratic functions handout, okay? You have the answer key there, but I'm going to do a few, just show you how it works. There's basically three types. Here's the first type. Let's look at number two. Here, you can read it. You can hit the pause button and read it. You basically have a rectangular garden that you're putting fencing around. Now, you know the rectangle, the perimeter would be 1,000 feet. So 2w plus 2l equals 1,000. And then what you can do is you're trying to find the maximum area. So what you can do here is you can get the area function in terms of just one unknown. And that is the key to a lot of these problems. So you can take the perimeter set equal 1,000 and you can solve it for L. And then you can plug that in here. So this is the area equals length times width. It turns out to be a quadratic function of just one variable. That's the whole key right there. Now, when the question is what dimensions give you the maximum area, you're talking about the vertex, right? And so since this is a function of w, if you look at negative b over 2a, and you plug those values in, that gives you 250 feet. So what is that? That's the value of the width that gives you the maximum area. Now, how do you find the corresponding length? Well, if you go back to what the length is, 500 minus w, you can see that in this case, it's going to be a square. It turns out it's not always a square, but in this particular case, the length should be 250 and so should the width. And the maximum area would be the product of those two. Let me show you an example. Not a square, okay? Let's look at number 3. Here it's the same situation, same exact situation, except you want to take some of the fencing and you want to create an extra piece of fencing here. Suppose you have two types of animals that don't like to get along too well together, so you might want to put another piece there. All right, so this changes everything. You have 1,000 feet of fencing, but here you have 3 W's plus 2L, see? So if you do the same problem, you're trying to find the maximum area still. It's still the area is going to be L times W. Here, when you solve for L, you actually get negative 3/2 W plus 500. So when you march over here and you put it in here, your area function looks slightly different, you see? You're still trying to find the vertex when it says what dimensions give you the maximum area. So once you get this formula, you're more than halfway there. Negative b over 2a will give you the width that gives you the maximum area. If you plug that in, negative b over 2a, you get 500 over 3, which approximately becomes 167 feet. Now, what would be the length? Well, to find the length that gives you the maximum area, you have to go back to here. And so you're going to plug w equal 500 over 3 in for w. And when you simplify this, you get that L equals 250 feet. Again, the maximum area would be the product. Oh, by the way, you have the answers to all these on the handout. On the back page are the answers to all these. And you also have the answer key. So that's the first type of problem you should be able to do. Let's call those the rectangle problems, because they're based on the area of a rectangle. A second type of problem on this handout is different. We're talking about the height of an object above the ground as a function of time. That's really important. The height is going to be in feet, and the time is in seconds. So we're going to use this formula. And if I ask you a problem like this, I would give you this formula. But again, this is the height of an object above the ground as a function of time. You'll always have a negative 16 in front that has to do with gravity, but you might not be given the initial velocity or the initial height. You have to find them. In numbers, I believe you are given each of those. Read it carefully. It says a ball is tossed directly in the air with an initial height of 5 feet, so that's h0, and then the initial velocity is 50 feet per second, so that would be v0. So you can just paste those on here. See, this is your function for the height above the ground as a function of time. So once you have the equation, it's not hard. How high is after 2 seconds? That's just h of 2. Plug in 2 and you get 41 feet. When does it reach its maximum height? So we want to know the value of t that gives it the maximum height. That's negative b over 2a, which turns out to be 25 over 16, which is about 1.56 seconds. What is the maximum height? You have to plug that value of t back into here. You can use your calculator to do that. It's about a little more than 44 feet. When does it hit the ground? Remember that they're asking you find the value of t when the height is 0. So you set this function equal to 0, throw it in the quadratic formula, and you get 3.22 seconds approximately. Let's do one more of those. So let's call these problems the height as a function of time, unless you can think of a better name. This is an interesting one. Suppose a baseball is hit in the air. Now this is a function of time. This is the function of time. All you know is that after 1 second, it's 84 feet high, and after 3 seconds, it's 148 feet high. That's all the information you're given. So you would be given this formula. Okay, remember I told you. So how do you find h0 and v0? That's kind of tricky. What you end up doing here is you use the information. You know that when t is 1, h is 84, right? So if you plug in 1 for t, here and here, you get this equation that says v0 plus h0 equals 100. Now we're going to plug in when t is 3 and the height is 148, and you end up getting another equation. I'm going back to here now. I'm plugging in t equal 3, so this becomes a 9 here, and 3v0, and h0, I'm plugging that in 3 there. Actually, I'm plugging t equal 3 and the height equal 148. I don't know v0 or h0, right? So you get this equation. Then what you do is you just solve the system of two equations, two unknowns. You could use the addition method, or you could use the substitution method. I chose the substitution method. I solved the first one for h0, plugged it into the second one, and you get that v0 is 96 feet and h0 is 4. Now that you know that, you can go back to the original equation. You see, I just found that v0 was 96 and h0 is 4. So now you can answer the last question, where when does it hit the ground? You set it equal to 0, throw it in the quadratic formula. So those are kind of a little bit messy. The last type I think is easier. The last type, if you read it really, really carefully, in this case we're talking about a football that's kicked towards a goal that's 70 feet. The crossbar is 10 feet high. I drew a little picture here. When I say football, I'm talking American football here. The football follows a parabolic path and reaches a maximum height of 20 feet. Oh, after traveling 40 feet, the maximum height is 20. So they're actually giving me the vertex. So let's call these problems the vertex problem, because they're actually giving you the vertex. And as you know, if you know the vertex of a quadratic function, you just about know the whole function, right? So I'm going to first find the equation for this quadratic function. That's the path of the football. Now, notice it's kicked. What is the initial height? There's no mention of the initial height. When you kick a field goal in football, it's kicked from 0. So I'm calling this point 0, 0. This is where the ball is being kicked from. And I'm going to get the equation for the quadratic function, and then I'm going to ask the question, does it go over the goalpost? That comes later. Okay, so let's just get the equation. I can plug in the vertex. Well, hk, this would be h, and this would be k. Don't get them mixed up. Now, how do you find a? Shouldn't a be negative because it opens down? The way you find a is you know that it's being kicked. I'm calling this the origin, so it goes to the point 0, 0. You plug x equals 0 and y equals 0. Don't get confused with what we just did. This is not the height as a function of time. This is the height, the vertical height as a function of the horizontal distance traveled. Totally different function than what we're talking about before. Anyway, okay. So you solve this for a, you subtract 20 divided by 40 squared, you get negative 0.125, which seems like a reasonable answer. So now that we have the equation that gives the path of the football, we can answer the question, which is it a field goal? So after 70 feet, I'm going to ask the question, if you plug in 70, is the height going to make it over the goalpost? Isn't this exciting? It's so exciting. I can't stand it. All right, plug in 70 in here. You simplify, and you get, it's too short. So the answer is no on this. Anyway, that's a sampling of the kinds of problems. Remember, you have the answer key for this too. All right, I hope that helps. All right, bye now.